We are interested in calculating the integral of x times tangent squared of x dx. First of all, we can break this guy down into smaller pieces. This can be written as the integral of x times, here you have secant squared of x minus 1 dx. So this integral in turns is the integral of x times secant squared of x minus x dx. And you can break it down into two integrals. The integral of x times secant squared of x dx minus the integral of x dx, which is very easy to work with. But for the first integral that you have x times secant squared of x, we're going to use the method of integration by parts. So this one is easy. You already know how to deal with this. For the first integral, we're going to use the method of integration by parts. In the method of integration by parts, we have the integral of u dv, which can be written as uv minus the integral of v du. So what's the choice of u and dv here? Let us take u to be x and dv be secant squared of x dx. With that choice, du is equal to dx and v is equal to the integral of secant squared of x dx. But when it comes to the integral of secant squared, as you remember, it's nothing but tangent. So v is equal to tangent of x. So we have all the missing information. This guy is equal to uv, which is x times tangent of x minus the integral of v du, which is tangent of x times dx. And this integral that I wrote down is easy, is nothing but a half x squared plus constant of integration. So let me move this a little bit further to avoid any confusion. Okay, so let us begin working with this integral here. So this guy, just x tangent of x minus the integral, but tangent of x is nothing but sine x over cosine x, and then you have your dx. And let us write down the rest of the integral, a half x squared plus c. When you're calculating the integral of sine x divided by cosine x dx, well, you have a choice of using ln, right? This guy is equal to the integral of, so let me use the same color, then show you what substitution we use in calculating the integral of sine x divided by cosine x dx. I'm going to use t to be the denominator, which is cosine x, then dt is minus sine x dx. So this integral can be written as negative, so you have a negative sign in front of negative sine x dx divided by cosine x. This guy in turns is negative integral of dt divided by t, which in turns can be written as negative ln of absolute value of t. But what is t? T is cosine of x. So this integral is negative ln of absolute value of cosine of x. So we're done with everything, right? This guy is equal to x, tangent of x, and you have a negative in front of it, so you get plus ln of absolute value of cosine of x minus a half x squared plus c. So we initially broke the integral down into smaller pieces. It was x times tangent squared of x. We wrote down secant squared of x minus 1 for tangent squared. Then we distributed x into parentheses. We get two integrals. The first integral, which is a little bit more difficult, we applied integration by parts for it. But for the second integral, which is easy, it is basically negative a half x squared plus c. We just copy it down. But for the first integral, here we used integration by parts method.